So welcome you to this last session before the mid-semester examination. And I'm sure you must be having few doubts from your homework or lectures. So I open the forum for any doubts, clarification that you might have.
Sir, a general question, sir.
Which one?
Sir, suppose a randomized estimator is given, and like the last day or a few days back we were explaining, and we are asked to find a better estimator. So there we find PTA, and then the distribution which comes at the end, we say that its risk is same as the delta given estimator. And
so there are two things. One thing is what I had said was you take any loss function. Doesn't matter which loss function you are taking.
Okay, sir.
And if you are given a randomized estimator, which is not a function of a sufficient statistics, let us say, right? Then you can find an estimator which is a function of a sufficient statistic and whose risk is same as that of a given estimator, right?
Yes,
so
sir.
And any loss function. This for any loss.
As taking the expectation, it will give the non-randomized estimator is better than the given estimator, right, sir?
Should give?
Means once we take the expectation, then it will give the non-randomized estimator, which is better than the given randomized estimator.
No, it would be have the same risk as that.
Then, sir, how to find the better estimator from there?
Better you can find only when your loss function is convex.
Okay, so I'm getting confused bit over. Okay, sir. Okay, sir.
If it's convex, you can find a better estimator, which would be a non-randomized estimator. And what would be this non-randomized estimator? Just take the mean of the randomized estimator.
Yes, sir. That is a probability distribution is there, and taking the mean of that will give me a
non-randomized estimator, which will be better than the given estimator. Is that okay?
Okay, sir. Now, sir, if it is given that we are provided with a non-randomized estimator and we are asked to find a better estimator, then how to proceed?
So, first of all, if it is not a function of a sufficient statistic, then condition it on a sufficient statistic.
Okay, sir.
Right. Whatever you get, that would be a better estimator than the given estimator.
Okay, whatever we are getting.
Whatever you are getting. Right.
Okay.
So, for example, let us look at this problem number 13 of assignment number 5, right? Shall I do it for you?
Yes, sir. Thank you, sir.
Okay. So let us try to see that. Yeah, so I think it seems since people are having a lot of issues with this. So I tried to do one problem yesterday where I was not able to find the explicit. So let us look at, I take a simple example, for example, and then you can think of a complicated example. So let us look at, I am giving this problem, right? Right. So suppose x1, let us take this problem itself, which is slightly complicated, but I'll do it. So let us look at, let x1, x2, xn be IID. So yesterday I had taken exponential theta 1. Today I am taking exponential 0 theta. Right? Where theta belongs to capital theta, which is 0 infinity. So what I would say is that in assignment problem number 5, you change that problem which I gave as a problem number 10, exponential theta 1 to you change exponential 0 theta, right? Just change that problem. I have done that in the Mookit platform. So don't do it for exponential 1 theta because you'll not be able to solve that integral. So exponential 0 theta you will get, right? Now, I consider a randomized estimator. Which is the same which is given over there. Randomized estimator. I am taking as delta x. So randomized estimator is always a distribution, right? Or a random variable, which is uniformly distributed n minus 1 upon n, x bar n minus 1, and x bar n minus 1. Now you can find a better estimator than this only when loss function is convex. But if nothing is given, then you can find an estimator based on a sufficient statistic having the same risk as this. So find a randomized estimator based on minimal sufficient statistic. So let me call that having the same risk as delta. Right? So you can, when nothing is given about the loss function, you can find a estimator which has the same risk as delta. Now, if loss function is convex, find an estimator. So let me find a randomized estimator delta 1 based, find an estimator better than delta. Second thing is, again, if loss function is convex, find a better estimator than delta 1, which you have obtained over here. So let's try to do this. Is the question clear to you?
Yes.
Right. So let us try to do it very systematically. Right. First of all, I need to find out what is a complete sufficient statistic in exponential 0 theta. Yeah, what is a complete sufficient statistic? Anyone? You need to respond, then I can answer your questions enthusiastically, and otherwise I will be much more dull than you, because it is your interest to ask questions, and if you are not enthusiastic about asking questions, how can you?
It's a mean.
Right, sample mean, right? So yeah, at least respond, so that you see, I feel that my energy is going for some good use, right? Otherwise it looks like I'm speaking to dead people, and that's very discouraging, right? I waste so much energy. I expect that you, being a learner, would be at least giving me some response. Good. So it is X bar is complete sufficient and hence minimal sufficient, because this would be required throughout, right? Okay. So I need to look at what is my delta X has PDF. So because I have to find the expected value of a PDF with respect to conditional distribution of X given T. So I just find out what is the PDF of PS. And PDF is for a fixed X, right? Because this estimator tells you after you have observed X, generate one observation from uniform n-1 by n X bar n-1 to this. So Px star A is basically 1 upon B minus A, so which is 1 minus n-1 by n, so which is 1. So this would be n times X bar n-1, indicator that this A has to be between n-1 by n X bar n-1 less than or equal to A less than or equal to X bar n-1. Note that X bar n-1 is the sample mean of the first n-1 observations, right? Is 1 upon n-1, summation I is equal to 1 to n-1. All right. So here, I have to take the expected value of this with respect to conditional distribution of X given T. Is that okay? So the estimator, the desired estimator delta 1 and what is the delta 1? Which has the same risk as delta. So the desired estimator delta 1 depending on minimal sufficient statistic X bar having the same risk as delta has PDF. What would its PDF? Its PDF would be expected value of this. So that would be, let me call this as P let us not put a star over here. Let us put a star in this PDF of delta 1. So let me just, yes, or I can put a double star, doesn't matter. P double star is the PDF corresponding to delta 1. T, because it will depend on the sufficient stress check. A, which would be expected value of this given T is equal to T. So that means expected value of N upon X bar N minus 1. The PDF, right? When you have to take the PDF. Indicated N minus 1 by N. Indicated, sorry, N minus 1 by N, X bar N minus 1, less than or equal to A, less than or equal to X bar N minus 1, given T is equal to T, that means given X bar is equal to T. Is that okay so far? Is it clear to you? Or?
Yes, sir. Yes, sir.
Okay. So I need to find out the conditional distribution of X given X bar, right? That is what I need to do. Looks like a simple exercise. I take N outside this over here. 1 upon X bar N minus 1. Indicator. I write down this probability in terms of X bar. So this is less than or equal to A, less than or equal to X bar N minus 1. And X bar N minus 1 is less than or equal to N upon N minus 1 A, given X bar is equal to T. Is that okay? So I need to calculate this. Now somehow I should, X bar is complete sufficient. So I should try to use the Passwords theorem so that I can get rid of this conditional expectation. For Passwords theorem, I'll need a statistic ancillary, which is here. And I can get an ancillary by considering X bar N upon X bar N minus 1. Is that okay? Because then X bar N upon X bar N minus 1 is ancillary. Right? So this is same as, now if I have to multiply by X bar N, I have to divide by X bar. But X bar is T. So that is same as N upon T. Expected value of X bar N upon X bar N minus 1. Indicator. Here also I want to convert everything into X bar N minus 1. And since T is positive, because X bar, Xi's are exponential, so they are positive. So X bar is positive, so I divide it by T over here. Less than or equal to X bar N minus 1. Because X bar N is same as T. I try to get ancillary and then I put here T fix. This is same as N upon N minus 1 A by T, given that X bar is equal to T. Any objections to what I wrote so far? Is that okay?
Sir, this distribution of xn bar by xn minus 1 bar,
Yeah.
sir, this will become ancillary. We have to show that.
You see, it is a scale family because you see, if you see your x1, x2, if you remember, I had showed you that if you have to show an ancillary, x1, x2, xn are IID with density f theta x, which is 1 by theta e to power minus x by theta, right? I can define, first I define something in terms of Zi, which is independent of theta. And in the scale family, you know that if you divide it by xi by theta.
By theta, yes.
Right.
That will make it independent of theta.
That would be independent. So then Z1, Z2, Zn are IID.
Okay, sir. Okay, sir. Okay, sir.
Exponential 1, right? Now, when you consider X bar N, right? For example, if you consider X bar N upon X bar N minus 1, it is 1 upon N summation Xi, which is summation theta Zi, upon 1 upon N minus 1, summation I is equal to 1 to N minus 1. This I is equal to 1 to N theta Zi. This theta gets cancelled. The scale family, normally these ratios you will see are ancillaries. Is that
yes,
okay?
Sir. Okay, sir. Okay, sir. Okay, sir. Thank you.
So if it was a location, I would have considered X bar N minus X bar
minus. Yes, sir. Yes.
Idea is to show it this way only, right? Okay. Now I can use the Passwords theorem because X bar is independent of x bar n minus 1 by x bar n. So it is ancillary. So this by Passwords theorem, this conditional expectation will be same as okay. Is that clear?
Yes, sir.
So now I just need to find this probability. Now first note that this is ancillary, right? That we have already shown because x bar n minus 1 upon x bar n is ancillary, and this all only depends on that, and distribution of z1, z2, zn does not depend on theta. So if it is ancillary, to make our life simpler without loss of generality, for calculation of this, we take theta to be 1. Just for calculation of this, right? Because I know that this is ancillary, so its distribution is not going to depend on theta. So whether you take theta 1, theta 2, theta 3, theta 4, doesn't matter. Since theta is equal to 1 is of convenience to you, me, I take theta is equal to 1. Is that okay? Because it is ancillary.
Yes, sir.
So let us look at x bar n minus 1 upon x bar n when theta is 1. This can be written as n upon n minus 1, and then summation I is equal to 1 to n minus 1 xi divided by summation I is equal to 1 to n xi. Is that okay? Which is same as n upon n minus 1. If you look at this quantity, this can be written as summation I is equal to 1 to n minus 1 xi, and then summation I is equal to 1 to n minus 1 xi plus xi, right? Can you tell what would be the distribution of this under theta is equal to 1? I gave this problem in the quiz also. What would be distribution of summation I is equal to 1 to n minus 1 xi? If theta is 1?
Beta.
Yeah, this whole would be beta. Yes, you're right.
Beta n minus 1, 1.
Good.
Yes.
Very nice. Right? Because x1, x2, xn minus 1 are IID exponential 1, which is gamma 1. So this would have a gamma n minus 1. Xn is gamma 1. And the two are independent. So this would have, let me call this as n upon n minus 1 times z, where what is the distribution of z? Beta n minus 1. Is that okay?
Right.
Okay, so if that is the case, then this becomes n by t, expected value of x bar n upon x bar n minus 1 becomes n minus 1 by n into 1 by z. Is that okay? 1 by z. Okay. Then indicator x bar n minus this was x bar n minus 1 upon x bar n, right? So x bar n minus 1 by x bar n is n upon n minus 1 z. So I can multiply both the sides by n minus 1 by n. So that n minus 1 by n, x bar n minus 1 by x bar n is z. So that means n minus 1 by n a by t is less than or equal to z is less than or equal to, I multiplied by n minus 1 by n, so this goes away to this a by t. Is that okay? Okay?
Yes, sir. Yes, sir.
Okay, good. Now I need to remember this because I am going to the next page. Let me write it down so that when I write down in the next page, this is n by t, expected value of n minus 1 by n, 1 by z, indicator n minus 1 by n, a by t, less than or equal to z, less than or equal to a. And z has beta n minus 1. Good. So let me just go to the next page. So let me write it down. Whatever I had written down, repeat the same line, which is same as n into n minus 1 by nt, right? N minus 1 into n by n into n minus 1 by nt, expected value of 1 by z, indicated n minus 1 by n, a by t, less than or equal to z, less than or equal to a by t. Note that I don't have to bother about this range being smaller than this because n minus 1 by n is always smaller. I know the distribution of z, so it is not a problem. The only thing is I have to, my z has to be between 0 to 1, and this is between this to this. So that means my z would be greater than or equal to maximum of 0 and n minus 1 by n, a by t. Z would be less than or equal to a, sorry, z would be less than or equal to 1 because it is a min beta, and z would be less than or equal to a by t. So it would be less than or equal to minimum of 1 and a by t. Then 1 by z. Density of beta n minus 1, 1. Beta, what is the density of a beta n minus 1, 1? Anyone?
Sir, 1 by beta n minus 1, 1 into x to the power n minus 2, 1 minus x, x to the power n minus 2 just.
That's all right. Is that okay?
Yes.
Good. This is what you've got. Now note that for this range to be meaningful, it is important that the upper range is bigger than lower range. Otherwise, it would be 0, right? Because this, then you have to integrate over something and null set. One minimum is bigger than or equal to maximum. That means each of the element would be bigger than or equal to each of the element over here, right? Because minimum of AB is bigger than or equal to maximum of CD. That means each of the element over here is bigger than or equal to each of the element over here. That means A is greater than or equal to C, A greater than or equal to D, B greater than or equal to C, B greater than or equal to D. Right? Because minimum is bigger than, that means each of them is bigger than maximum. But maximum is less than or equal to, that means each of them is less than or equal to. That is the concept. So for this to be meaningful, 1 should be bigger than or equal to 0, which is always true. And 1 should be bigger than or equal to n minus 1 by n 80. So that means 1 should be bigger than or equal to n minus 1 by n 80. Now, since I'm trying to find the distribution with respect to A, because my variable is A for a fixed C, so this would be if A is less than or equal to n upon n minus 1t. So that is the one condition I get. Second thing is A by t is bigger than 0. So A greater than 0, anyway I take t because that means A is greater than 0. And A by t is bigger than or equal to n minus 1 by n, that is true. So A is between 0 to n t, n upon n minus 1 t. This is what condition I need. Now, if that is the situation, I know that A is bigger than n minus 1 by t, but here it could be anything. So this you can solve, right? This becomes n into n minus 1 square, right? This nt gets cancelled. So n minus 1 square by t. And then it becomes z to power n minus 2. And when I take it, it becomes z to power n minus 1. So this goes away. And then minimum of 1 of a by t. So let me write those correct very precisely because I'll need it for. So let me. So this is what I get for a between 0 to n into n minus 1 by t, and otherwise it is 0, right? Because otherwise this density over here would be 0. So, okay, so this becomes n minus 1 whole square by t, right? If I'm making any error, just let me know. And then z to power n minus 2, that becomes z to power n minus 1 by n minus 1. So this also goes away. And then minimum of 1 a by t.
So inside the integral, it is 1 by z into z to the power n minus 2 only.
Yeah, so
because
z to power n minus 3 it becomes, right? So yeah, so
yes,
you're right. You're right. Yeah, thanks for pointing it out. Yeah, so you have to be watchful, and if I'm making any calculation error, you have to just correct me. So n gets cancelled, so this is n minus 1, and then z to power n minus 3 it becomes. Z to power n minus 3 when integrated will give you n minus 2 over here. You're right. So this to power n minus 2 minus maximum of n minus 1 by n a by t under this range is anyway n minus 1 by n a t. So maximum of maximum is always this. So this to power n minus 1 by n a by t whole power n minus 2. Now it depends, and this is 0 otherwise. So n minus 1 by n minus 2 t into, now depending on whether a is smaller than t or not, a is less than n upon n minus 1 t. So this has two branches where a is less than t, because n upon n minus 1 is bigger than 1. So a is less than t and greater than 0. Then what happens? A by t is less than 1. So then it would be a by t to power n minus 2. And then that becomes common here also. That becomes 1 minus n minus 1 by n to power n minus 2. Just make sure that I'm not making any mistakes. The ideas are very simple. Now, when a is bigger than t and less than n upon n minus 1 t, then this quantity, then I know that a by t is smaller. So this becomes 1 minus n minus 1 by n to power this becomes 1, and then n minus 1 by n to power n minus 2 into a by t to power n minus 2. So this is the estimator which you get. Is that okay? So this will have a same risk as this. So what is this estimator? I was calling that, I think, as delta 1x. Delta 1x is nothing but n minus 1 upon n minus 2. In fact, I can take everything inside. So n minus 1 upon n minus 2. A to power n minus 2 divided by x bar to power n minus 2. And then 1 minus n minus 1 by n to power n minus 2. If a is between 0 to x bar, and if a is between x bar to n upon n minus 1 x bar, then it is 1 minus n minus 1 by n to power n minus 2 a by t to power x bar. Is that okay? Is that okay? So this is an estimator which has the same risk as delta. Any doubt in this so far? Because then I can move to the second one.
no, sir.
Is that okay? Okay.
Sir, one more thing, sir. I think the n minus 1 within the integral, that will also come out and contribute to the n minus 1 whole square.
Which one?
So 3 steps ago, there are one n minus 1 inside the integral, which will also come out and
inside the, oh yeah, this integral is there. Yeah, so this will
that
come
will also
out.
be there as a square, I think.
Yeah, yeah. So I think there was those calculations you can see. I've told you the idea of.
Yes, sir. Yes, sir. Yes, sir. Understood, sir. Understood.
Yeah, so you can make it n
Thank you.
square. Can make it n minus. And this I think would also come over here, right? That I have not taken over here. So write it. Okay. Done. So now the second part says if loss function is convex, find an estimator better than this. Now I've told you that if a convex loss function, you can get a better estimator by just getting the mean of this distribution. So what is that estimator? It is a mean of Uniform AB. What is the mean of uniform AB?
So A plus B by 2.
A plus B by 2. So n minus 1 by n plus x bar n minus 1 plus x bar n minus 1 by 2. Is that okay? And how much that becomes? 2n minus 1 by 2n x bar n minus 1. Is that okay?
Okay, sir. That means that whenever we are asked to find directly a better estimator, then we need not do all these calculations and just simply take the expectation of the.
Then you have to
given
directly
estimator.
find the UMV. Yeah, here you are not asked to find a UMV, you have to find an estimator which is better than this.
Yes, so then we can take the expectation of it directly because the distribution is given to us.
If this one is given to you, that would be better than this. But now you know that this estimator does not depend on a complete sufficient statistic. So you can even improve this.
Okay.
And how do you improve this? By conditioning on a sufficient statistic. Is that okay?
Yes, sir.
Is it all right? I can condition this on a sufficient statistic. But I'll come to that. I'll come to improving this also. But let us look at what is the second. If the loss function is convex, find an estimator better than this. Now, this distribution you have already got. This would be a proper probability mass function, right? So if you want, in fact, this n minus 1 whole square upon n minus 2, you can keep outside only. So this has a PD of this, right? Delta 1 has PD of this, n into 1 by t. Now to find a mean of this distribution, so estimator improving upon delta star x would be the mean of this distribution. What would be mean of this? N minus 1 upon n minus 2 into 1 by t multiplied by mean of this with respect to a. So that means a to x bar. This t here is x bar, right? So this x bar comes over here. So if you want, you can keep it here, doesn't matter. And then integral 0 to x bar, right? A to power n minus 2 upon x bar to power n minus 2, and you keep on doing it, right? If a is between 0 to x bar, right? Plus dA, and then plus x bar upon n plus 1 x bar, a times, there would be a over here because you're talking about mean, and then 1 minus n minus 1 by n to power n minus 2, a by t to power x bar to power n minus 2 dA. You can calculate this, right? Is that okay? Because this was a PDF and you have to get a better. So now let us look at when I improve this estimator delta x, I got when I found an estimator which has the same risk as this, it is this. But if I have to find a better than this under convex loss function, I have to get expected value of this, right? So let us look at an estimator improving delta star x. What was the delta star x? N upon n minus 1 or n minus 1 upon n? What I have obtained there?
So n minus 1 by
n minus
1 by n minus 2 into 1 by t and the expectation.
Oh, that estimator I have obtained is something else, right? Oh, this
over
is 2n
there
minus
is
1 upon 2n minus 1 upon 2n x bar n minus 1, right?
Yes, yes.
Yeah. What was that? 2n minus? Can you repeat it for me?
2n minus 1 by 2n into xn minus 1 bar.
X bar n minus 1, right? So improving is delta star t, which is delta star of x bar. X bar is based on all n observations. This is same as expected value of 2n minus 1 by 2n, x bar n minus 1, and x bar. Is that okay? These are estimated, but I can calculate this. Again, x bar is complete sufficient. So I try to make it ancillary. I divide it by X bar, and X bar is constant, so that can go outside because X bar is fixed. Is that okay? X bar is fixed, so I have multiplied it. Now this is ancillary. This is complete sufficient. So this is same as 2n minus 1 by 2n X bar into expected value of X bar n minus 1 by X bar n. This distribution we have just seen, it is 2n minus 1 by 2n X bar into n upon n minus 1 into expected value of z, which is beta n minus 1, 1. So how much this turns out to be? N times 2n minus 1 upon 2n into n minus 1. Expected value of z is 0 to 1, z. The distribution of this is this, so that is how much? Beta n minus 1, z to power n minus 2, right? Which becomes, there's X bar over here, so this becomes 2n minus 1 by 2 times n minus 1. And this n minus 1 gets cancelled with this, right? So 2n minus 1 by 2. And how much that becomes? That becomes z to power n minus 1, right? That becomes 1 by n, right? So 2n minus 1 by 2n X bar. So that is an estimator which improves upon this. So you got the same one? No. Yeah. So this estimator. Is that okay?
Yes, it's a better estimate.
This is a better estimator than this one.
Okay, sir. Okay, sir.
Right.
So we did this because now the estimator we have just obtained is dependent on based on the sufficient statistic.
Yeah, complete sufficient, minimal sufficient.
Yes, minimal sufficient statistic. Okay, sir.
But still, I cannot say whether this can be improved or not. I know that this is better than this. Whether you can improve this or not, I do not know. If I have to do that, what I do is I look at, certainly it suggests that my estimator should be some constant time X bar. This constant may vary. So it may suggest that I should look at estimators of the type C times X bar. Right? So let's look at, so let me call this as delta C. And I'm trying to find an estimator which is best among estimators of the type delta C. Now note that for me, unbiasedness is not a criterion, because expected value of delta C, because UMVU, you know, is X bar. So certainly this cannot be UMVU because it is not even unbiased. But as I have told you that if you are willing to sacrifice a little bit on unbiasedness, you may get estimators which are good, right? Which have a smaller risk. So let's try to see. Because if I just look at UMV, there is a unique UMV based on X bar, which is X bar. Right? So I'm not interested now in UMV. I'm trying to find out an estimator of the type C, because these all estimators are not UMVs. They are estimators better in terms of a risk function. Their risk is smaller, right? They may not be unbiased. Is that clear?
Yes, sir.
Yeah. So let us try to see among estimators of the type C times X bar, what is the best estimator? So that is same as expected value of C times X bar minus theta whole square. Now this can be written as variance of C times X bar plus the bias of this, which is expected value of C X bar minus theta whole square. So this is called variance plus bias, because you know that expected value of X minus C or D whole square can be written as always expected value of X minus expected value of X plus expected value of X minus D whole square, which is expected value of X minus expected value whole square is variance of X. Cross product term, this is constant, and expected value of X minus expected value of X is 0. So plus expected value of X minus D whole square. That is what I have written down. variance of C x bar is same as C square variance of x bar. Variance of x bar is sigma square by n. Right? What is the variance of exponential? What is the variance
The
of
theta square.
theta square, right? So it is C square theta square by n. Right? C square, and then variance of x bar is sigma square by n, so theta square by n. Expected value of C times x bar minus theta would be C times expected value of x bar is theta. So C minus 1 whole square into theta square. Is that okay? Is that okay? I hope I have variance C x bar plus expected C x bar minus, yeah. So this is the thing. So I have to minimize this respect to theta. So this would be minimum, theta square comes common. So it becomes C square and C square with 1, so that will become n plus 1 by n C square minus twice C plus 1. So this quantity, if I have to minimize with respect to C, this would be minimum and this is minimum. And what is the minimum value possible? C is equal to n upon n plus 1. Right? So even this estimator can be improved upon by n upon n plus 1 x bar. So yeah, so one has to keep playing around to get improvements over each other. Is that okay?
Yes, sir.
Yeah. I hope this clarifies everything about randomized and non-randomized estimators.
Yes, sir. Thank you, sir.
Any other doubts anybody has? So even if you are having doubts in between, I have to do some traveling in between, but I can try to, means I don't guarantee, but I will try to find out sometime on Sunday morning. So Sunday, let us say 7 in the morning. If somebody of, I'll try to join the Zoom. And if any one of you are keen and you still have a last minute doubts to discuss, I can make, try to be available at 7 a.m. on Sunday morning. So any one of you have any last minute doubts, feel free to contact me during that time. I'll be in Delhi, so I'll try to find out some place where I can get a network connection and try to interact with you. Yeah, so any other doubts? So Sunday I will be available. So if you have any doubts, Sunday at 7, feel free to contact me. Any other doubt anybody has? You can ask anything, right? However trivial doubt it may be. Yes, anybody?
Hello.
Yeah, Sagun, tell me.
So in question number 12,
Which assignment?
5.
5, question number 12. Let me see it. Okay, right. Right.
In this, will the distribution of delta x be Bernoulli?
Yeah, so here, for example, let us look at 12. X is given to be binomial and theta. Theta belongs to capital theta, which is 0. All right. For estimating theta under the square error loss function, consider the estimated delta x. So delta x is a random variable such that probability that delta x. So delta x has a certain distribution, x by n, which is same as probability that delta x is equal to half. Sorry, delta x equal to half is half. Right? Find a randomized, non-randomized estimator better than delta. Right? Find a non-randomized estimator better than, also calculate the risk of 2 estimators. So find square error loss function, which is convex, so I can always find so squared error loss function. I know is convex, so L theta D is nothing but d minus theta whole square. And I know that is a convex function of d. Because I need L theta d to be convex in d. And it is convex function of d because if you take the double derivative of this quantity, you get 2, which is positive. And you know that if double derivative is positive, then your function is convex. So it is convex. Now I know that if my loss function is convex in d, given any randomized estimator, I can get a non-randomized estimator which is better than this. So find a non-randomized estimator better than d. Yeah, so first let me ask you, what was your doubt?
So here will the distribution of delta x be Bernoulli?
No, delta x takes two values only. Delta x takes value x by n with probability half. It takes half with probability half. So delta x, if you look at, is x by n. For a given x, it takes value x by n with probability half. And it takes value half with probability half, right? So it is not Bernoulli. So just recall whatever I said right now. If you have to find, under the convex loss function, if you have to find an unbiased estimator better than a given randomized estimator, you take its mean. So the estimator dominating, or which has a smaller risk, delta x is delta star x, which is expected value with respect to the action you are talking about of delta x. Note that this expectation is not with respect to x, it is with respect to the action, this probability distribution. Is that clear? Because delta star x I have to find for a fixed x. What will be this quantity, Sagan?
So x by n to 1 by 2 plus 1 by 4.
That's all. Done. So this will be 4n. Yeah, so you can write down just this as, so delta star x is x by 2n plus 1 by 4. This estimator is better than this estimator delta, right? That you know, because convex loss function is given to be convex, that you already know. Was this your doubt?
Yes, sir. And so for the loss function, for the risk function, we'll find the expectation of
Yeah,
the.
so let us look at risk function, right? You see, risk function of non-randomized estimator is straightforward to find. So the risk of this is very easy to find. I find out just x upon, so let me call this as delta star, x by 2n plus 1 by 4 minus theta whole square. Is that okay? This is same as, again, you can write down this as variance of this quantity. Variance of x by 2n plus 1 by 4 plus expected value of x by 2n plus 1 by 4 minus theta. Just the thing which I wrote down right now, x minus c whole square is same as variance of x plus expected value of x minus c whole square. So it is variance of this plus expected value of this minus this whole square. This is same as variance of x by 2n, so which is same as 4n square times variance of x. This is same as expected value of x is, I know that as n theta. So it becomes theta by 2. So it becomes 1 by 4 minus theta by 2 whole square. Variance of x is nothing but n theta into 1 minus theta, because x is given to be binomial. So theta into 1 minus theta by 4n plus, yeah, 2 theta minus 1 whole square by 16. You may just check whatever it is, and you can get it. So there is a, now finding a risk function of this will involve two-stage expectations. One, expectation with respect to this distribution, and then expectation with respect to x. So First, let us look at the first stage randomization, which will give me R theta delta X, right? Which is expected value of the first expectation is to A of delta X minus theta whole square. What will be that? I know that delta X takes value X by N with probability half, so it will be X by N minus theta whole square into half. Plus, it takes value half with probability half, so it is half minus theta. Is that okay? Seven?
Yes,
Okay. Now I have to take a second expectation to get the risk. So R theta delta would be nothing but expected value of L star of theta of delta X, which is half times expected value of X by N minus theta whole square plus 2 theta minus 1 whole square by 4. Now this is same as expected value of X by N minus theta whole square is same as variance of X. Variance of X is nothing but N theta into 1 minus theta. It would be the variance of X by N. So it would be 2 N, right? Because it will be N theta into 1 minus theta by N square. So theta, yeah. So plus twice theta minus 1 whole square. Now you can see that this is smaller than this, right? You can directly see that theta, this is theta into 1 minus theta by 4n, because this randomized estimator anyway, I'm claiming that this has a smaller risk than this. And in fact, you can calculate the exact risk and see that this is smaller than this. Because delta star I have already shown, not finding the risk function, but through that Rao-Blackwell theorem or that results which I did in the lecture, that this estimator is going to be better than the delta, which you have also done indirectly now by comparing the risk functions of the two, and you see that the risk function of delta star is smaller than the risk of delta. Risk of delta is theta into 1 minus theta by 2n plus 2 theta minus 1 whole square by 4. Here it is same as theta into 1 minus theta by 4n plus 2 theta minus 1 whole square by 16. So this is much smaller than this. Does that clarify your doubt, Salan?
yes, sir. Thank you, sir.
Any other doubt anybody has?
So just one more clarification.
Yeah.
Sir, this means that the whatever be the loss function given, we have it's used in only two places. Firstly, if we have to check if it is convex, then we can find the better one.
Right.
And then while finding the risk function, we take the expectation of that or expectation of expression of that, whatever. Means loss function is used in only those two cases, right, sir? Meanwhile, finding the estimator, we have no use of loss function.
By finding finding a better estimator, loss function is nowhere used. It has been indirectly used in proving that result. Right?
Yes,
because
yes,
you applied
yes,
the Jensen's inequality on the loss function, right? And
yes,
as
sir.
long as loss function is convex, the Jensen's inequality is applicable, so you will get a better estimator.
Okay, sir. And while finding the risk function, then we need
And
the
you
loss
need,
function.
because risk function is always with respect to a loss function, right?
Loss function. Okay, sir. Okay, sir.
So for every risk function, there is a loss function associated with it, because you cannot find a risk without a loss. Right?
Yes, yes, sir.
You can find a better estimator without a loss function if you just know the convex. For example, here I have considered squared error. Even if the loss function was delta x minus theta, under this loss function also this would be a better estimator. Any convex loss function, this would be a better estimator than this estimator, right? Because that is what your result says. You take any convex loss function, this estimator would be better than this. But when you have to evaluate the risk exactly, you need the loss function, what it is.
Right, sir. Right. Sir. Thank you, sir.
Yes, any other doubt anybody has? So if you want to see me on Sunday, you just drop me an email. Otherwise, I may not come because there is no point in just sitting over there and nobody coming over there. So if you have, any one of you have doubts, you can always write an email to me, and then I would be available for clearing your doubts at 7 in the morning on Sunday. Does that sound good?
Yes, sir.
Okay, great. Any other doubts anybody has?
Sir, one more doubt from question
Yes.
number 10.
Question number
10, sir.
10 of which assignment?
5.
10 I did right now, na?
Sir, you have in the assignment you have changed the distribution of delta x.
So you do it with the changed one only. Do it with exponential 0 theta. With exponential theta 1, it is getting very complicated.
No, sir. For the distribution of delta x, you have given uniform x bar minus 1 by n, comma x bar plus 1 by n.
No, I think you are looking at the old homework. Just see the new homework. Right, there were few typos. I have changed it. Now your problem number 10 is same as what I did today. Is that clear? Just see the new sheet in the MOOCit platform. It has been changed. That typographical errors have been corrected over there. So now the problem which is posted on MOOCit is with uniform n minus 1 upon n x bar n minus 1, comma x bar n minus 1. So I have just changed the problem a little bit so that your calculation becomes manageable.
Okay, sir.
Okay, you can just see the latest version of the homework over there. Any other doubts? Feel free to ask any doubt you have. I'm free. I don't mind staying back and answering as many questions as you want.
Sir,
Yeah.
sir, I have a doubt in a quiz question. Can I ask now?
Yeah, sure. You can ask anything. Why now? Yeah.
So the part 2 of question 2.
Can you read me a question, because I don't have a quiz right now directly in front of me? If you can
Yes,
just,
sir. Yes, sir.
yeah, just read it for me. I'll be, yeah. So what is the question?
So it says let x1 to x10 be a random sample from the geometric distribution, and then I am required to show that let y be defined as.
What is the geometric distribution? PMF is given?
Yes, sir. It's f theta x equals
Right.
theta into 1 minus theta to the power x minus 1 for
Okay.
x equals 1 to.
X equal to 1, 2, and so on. Right. Then what is the question?
Then we have y equals I equal to 1 to 10 summation xi.
Right.
We are required to show that S, which is defined as y square minus y minus 2 for y equals 10 and 11.
For y belonging to 10 and 11, right?
And y square minus 23y plus 240.
23y minus 240, yeah.
Plus 240.
Plus 240, okay, great.
For y equals 12, 13, 14, and so on.
12, 13, 14, and so on. Okay.
We have to show that S is sufficient for theta.
S is sufficient for theta. So let us try to see. This is a conceptual question. Let us try to see if T is given to be a sufficient, right? T is sufficient. And if there is some other statistics S, which I have to prove sufficient, what relationship it should have with T? T is sufficient. If there is some other statistic S, and I want to show that S is sufficient, then S should be what?
So one-to-one function.
A one-to-one function is always there, but you need much less than that.
A function of T.
Not function of T. If T is a function of that statistic, then that statistic is also sufficient, right? So if,
Yes.
right, if T is a function of S, then S is also sufficient. Is that okay? And that makes sense because it says it is enough to know the knowledge of T. But I'm saying for the knowledge of T, from the knowledge of S, I can get a knowledge of T because T is a function of S. So that means S is also sufficient. So that is a simple, that is okay. Now, if you have two minimal sufficient statistics, and second thing is minimal sufficient statistic is a function of every sufficient statistic, right?
Yes, sir.
That also. And you know that if T is minimal sufficient, and S is 1-to-1 function of T, then S is also minimal sufficient. Is that okay?
Yes,
The
sir.
third is about completeness. If T is complete, then any function of T is complete. It is not like sufficiency. In sufficiency, if you want to show that S is sufficient, then S should be then some sufficient statistic should be a function of S, right? That is what you need. But in completeness, any function of a complete statistic is complete. If T is complete, implies that any function of T is complete. So these are the things you just need to remember. Right. Now, in this case, I know what is a minimal sufficient statistic. Is that okay? This
Yes, sir.
why is minimal sufficient? Is that okay? So
Yes.
if S is sufficient, then Y should be a function of S. Because minimal sufficient statistic is a function of any other sufficient statistic.
Yes, sir.
So if S is sufficient, then Y should be a function of S. So that means I just need to see whether Y is a function of S or not. So I see the behavior of S with respect to Y, right? So you see, to show that S is a sufficient, then Y should be a function of S. What does that mean? That means given the value of S, I should be able to get Y, right? That is what it means. So let's try to see the behavior of ds by dy. For the time being, although here variables are given to be continuous, I assume Y to be variables are discrete because 10, 11. I can assume because monotonic behavior, I can always consider in the continuous part itself, and then it will hold for a discrete also. So I consider the derivative of S with respect to phi. What is this quantity? 2y minus phi. If y is, let us say for y greater than y belonging to 10, 11. I'm seeing a discrete phi, but taking it continuous, because if a function is increasing in continuous points, it will be increasing in discrete points also. What is this quantity? 2y minus 23. Is that okay? If y belongs to 12, 13, and so on. So note that when y is bigger than 12, it is strictly increasing, right? At y is equal to 12, it is 24 minus 23 bigger than 1, right? 26
Yes,
minus, and y is equal to 10 onwards also, it is strictly increasing, right?
Yes, sir.
So this looks like a strictly increasing. Have I noted down my S correctly or not? Have I noted down my S correctly?
Sir, S is y square minus y minus 2, not 21.
Minus 2. So it is 2y minus 1, it is over here, right? I should take the calculator. So that is okay. 2y minus 1 and 2y minus 23. Here it is increasing. But here, if you look at y square minus y minus 2, you are talking about, right?
Yes, sir.
Okay. So let us look at that 2y minus 1. Y is equal to 20. Yeah, it is always increasing. What about this? This is also always increasing, right? 2y minus 23. So yeah. So y is equal to 12, 24 minus 23 is 1. So that is okay. So this always looks like an increasing function. So S and Y, that means are one-to-one function, right? If they are one-to-one function, then that means if Y is minimal sufficient, S would also be minimal sufficient. So for example, you can look at what is the value of S at different Y's. From here, I get that S should be an increasing function of that. That just to check that I have made a correct calculation. Y is equal to 10. What is the value? 100 minus 12.
Sir, 88.
88. And Y is equal to 11.
Sir,
121.
108.
108. Yeah, so you see, what is happening is here, Y is equal to 10, 11 onwards, there is no problem. Within this, it is increasing, within this increasing. So the only thing I have to check at 11 and 12. What is happening at 11 and 12? What is a Y is equal to
12
11?
also same value is coming.
So that is what you see 108. Right? Because in this whole range, I had seen it is increasing. In this whole range, I had seen increasing. But I say that when it goes from 11 to 12, it is not strictly increasing. It is the same value which you get. Now, same value you get, what does that mean? I had to show that if S is sufficient, then Y should be a function of S. That means given the value of S, I should be able to get Y. But given S, suppose I am given S to be 108. Can I get the value of Y?
No, sir.
I cannot get value of Y. Since Y, which is a minimal sufficient statistic, is not a function of S. It is not a function of S. Why? Because two different points, same point is going to two different points, right? Because you know that S of 11 is same as S of 12 is 108, right? Because function, if S was a function of Y, two distinct points cannot go to the same point. So given the value of Y, you cannot get the value of S. And since the minimal sufficient statistic has to be a function of every sufficient statistic, this says that S is not sufficient. Does that clarify your doubt?
Yes, sir. Thank you, sir.
Okay. Any other doubts?
Sir, does method of movement estimators also follow invariance property?
Yeah, there actually that is how we have defined. Because method of movements, there is no way to define method of movements for a function of this, but that we have given as a definition. We have given a definition that if theta hat is method of movement estimator of theta, then g theta hat is method of movement estimator of g of theta. That we have taken just by definition. Right? There is no proof required, right? Because it is a definition.
Okay.
Okay. Okay. Any other doubt anybody has?
Sir,
Yeah.
sir, in this problem of the quiz which was just discussed now, sir,
Right.
I had shown the calculation of S for different Y, and then I have seen that for Y equals to 11 and 12, it is the same while the others is increasing. And sir, then I had shown in a way that probability Y equals to 11 means a certain value of Y given the value of S depends on theta, and so it cannot be sufficient. Will that be
also
okay
is
or
so.
something?
That way also you can show.
Okay, sir. Okay, sir.
You can show it anyway. I just saw because I already knew what is a minimal sufficient statistic. So I can, if S was sufficient, it has to be a function of this, right?
Right, sir. Okay, sir. Understood now.
Any doubts?
So in question number 5 of assignment 5,
5 of assignment 5, yes.
so will the MLE be xn? Yeah.
I'll have to check this. Let me just see. This is assignment number 5, right? Problem number 5, right?
Yes, sir.
Okay. Let me see. I have to do some of these on my scrap sheets. Let's see if I can. No, it will depend on X also, right? Because you see, what is happening is problem number 5, you are saying, right? So if you consider the log likelihood function, Lx theta is, there are two observations only, so 4 by theta to the power 4, right? Theta minus x1, theta minus x2. If each xi is less than theta, so that means theta is bigger than x2. 0 otherwise, all right? Which is same as 4 by theta to the power 4. I can write down each of them in terms of order statistics itself. Theta minus x1 into theta minus x2. If theta is greater than x2, 0. Is that clear? So this is my likelihood function. Is that likelihood function clear?
Yes, sir.
So I need to maximize this quantity, right? Because here it is 0. So maximum would be only in this range. So that, because this is a positive quantity. So I look at the log of likelihood in that range, in this range. That is log of 4 minus 4 log theta. Note that here density is not constant. It is not like a uniform case. In uniform case, this was constant, and then you could say that, or it was a decreasing function of theta, you could say. So I have to see what is the behavior of this function. So log of 4 minus 4 log theta plus log of theta minus x1. Now note that taking log is not a problem because theta is bigger than maximum, so theta would be bigger than each of them. Plus log of theta minus x2. Your range is theta is bigger than. So I take the derivative with respect to theta and try to see what is its behavior. It is minus 4 by theta plus 1 upon theta minus x1 plus 1 upon theta minus x2. So I see this behavior for theta greater than x2 just to get my maximum or minimum. So I can take here theta, theta minus x1, theta minus x2. Then it becomes minus 4 times theta minus x1, theta minus x2, plus theta into theta minus x2. And then plus theta into theta minus x1. Okay, this is same as theta into theta minus x1, theta minus x2. How much this becomes? First, I calculate the coefficients of theta square. So minus 4 theta square plus theta square. So minus theta square. 4 theta minus 4 theta square plus theta square minus 3 theta square minus 3 theta square plus theta square minus 2 theta square. I can calculate the terms of coefficient of theta. From theta, I get here minus x2 minus x1. So 4 times x1 plus x2. Right? 4 times x1 plus x2. And then x2 and x1 go away. So minus 3 times x1 plus x2 into theta. So that becomes theta. And then I consider the cross product term. Cross product term is only plus 4 x1 x2 minus 4 x1 x2. I can take the minus outside. This will be plus, right? Because yeah, so 2 theta square minus 3 x1 plus x2 and what will be this? Plus 4 x1 x2. This is a derivative, right? I will not go for a double derivative test. I just try to see what is the behavior of this function. So d by d theta of Lx theta is positive or negative depending on. Note that denominator is always positive because theta was bigger than x2. And theta is anyway bigger than positive quantity only. So this is positive. So that means this will be positive if this is less than 0. So that means twice theta squared minus thrice. So I can write down 2 also. I can just get rid of 2 minus 3 by 2. Theta square minus 3 by 2. X1 plus x2. Plus 4 by 2, which is 2 x1 x2.
There is one theta multiplied with
Yeah,
3.
less than or greater than 3. Is that okay? So the behavior would be like this. Is that clear?
So there is one theta multiplied with
Where theta is multiplied?
minus 3 into theta.
That I have written x1 plus x2 into theta. Minus 3 theta. That is okay, huh? Up to here it is okay. So I try to see that when this is positive, this will be positive and this is negative, right? So that means theta square minus 3 by, I multiply by 2 because sign doesn't change by multiplying by a constant. So theta square minus 3 by 2, x1 plus x2, there will be a theta over here. Plus 4x, well, so 2x1. So this is this. Now this can be written as theta minus, let me call this as alpha, and theta minus beta is less than or greater than 0. So I try to see what are these alpha and beta? Alpha and beta are roots of this equation, right? You see, I have it would be clear to you why I had divided it by 2, so that the coefficient of theta square is 1, so that I can write down this as theta minus alpha into theta minus beta, because in theta minus alpha and theta minus beta, coefficient of theta square is 1. And that is the reason why I wanted to write down this as a polynomial. Is that clear? Can I write down like this, Sagan?
Yeah.
Okay, so I just need to calculate the roots of this equation. So alpha betas are nothing but root of this equation is minus b, which is 3 by 2 x1 plus x2 plus minus square root of b square, which is 4 by 9 x1 plus x2 whole square, b square minus 4ac, so minus 8 x1 x2 b square minus 4ac by 2a, which is 2. All right. This becomes how much? 3 by 2 x1 plus x2 plus minus how much that becomes?
So it will be 9 by 4.
This will be 9 by 4.
Yes, sir.
Let me just check. Beta square. Yeah, this is 9 by 4. 9 by 4 x1 plus x2 whole square minus 8 x1 x2. That is okay. And how much is this turns out to be? Square root of 9 x1 square plus 9 x2 square, and it would be 18 x1 x2 minus 13 minus 32, so minus 14 x1 x2 divided by 4 will come from here, So 1 by 4 will come over here, right? That is what it is, 1 by 4. Is that clear? Okay. So by 2a. So this is what it is. Just make sure that I'm not making any calculation mistakes. Now this quantity, if I look at, what can you say about this quantity? Somewhere this 2 factor is creating a problem, but
1 by 2 plus minus 1 by 2
what happens? This will be 1 by 2.
plus minus 1 by 2 that comes outside the root.
Oh, that will be plus 1 by 2. Yeah. So this comes over here and then it becomes 4 over here. Is that okay? Okay. Now you can call this as alpha with a minus sign and beta with a plus sign. Right? So alpha less than beta. So what you can see is from here, if I try to rank these alpha 1 and alpha 2, because my range has to be greater than x2, because my theta is bigger than x2. So I have to locate this point in relation to point x2. Can you tell which one would be bigger than x2 and which one would be smaller than x2? With a minus sign, can you say that it will be bigger than x2? No, you can see that alpha, which is 3x1 plus x2 minus square root of this, would be smaller than x2. That you can see by solving this inequality, right? That doesn't make. And similarly, you can show that x2 is less than or equal to beta. So this range which you are getting as theta bigger than x2 lies between alpha and beta, which are root of this. And your likelihood function is positive if this happens. So let's try to see what is its sign, because my theta is bigger than x2. So let us look at what happens between x2 to b. In x2 to b, theta minus alpha is positive. This is negative. So that means this would be increasing up to b. What happens after beta? This is positive. Theta minus alpha is positive and theta minus beta. So this would be decreasing. Right? So your derivative would be positive over here. That means x2 to beta it would be increasing and then so where is the maximum? Anyone? The maximum occurs at theta is equal to beta. So your MLE is beta, which is nothing but given over here, which is 3 times x1 plus x2 plus square root of 9 times x1 square plus 9 times x2 square minus 14 x1 x2. Now note that it is symmetric in x1 and x2. So whether you write ordered or unordered, it is same because this can be written as 3 times x1 plus x2 plus square root of 9 times. Similarly, this also is symmetric in x1 and x2. So this is also same as 9x1 square plus 9x2 square minus 14 x1 x2. Sounds good?
Yes, sir.
Okay, good. A slight basic calculus, but yeah, you have to be a little bit careful. The only tricky part over here is not tricky part because you have to look at the behavior of the function for theta greater than x2. And since it is getting 2 roots, I write down those roots and see the behavior with respect to these roots. And it so turns out that one of the roots of this equation turns out to be the ML. Yes, any other doubts anybody has? Any more doubts or should we disperse for the day? If you have any doubts, feel free. Yeah, Prithvijit, do you have any doubts?
No, sir.
Okay. Anybody having any doubts? Okay, then if there are no doubts, then maybe you can disperse for this. And if you have any difficulties, please feel free to send me an email. I would be glad to explore the opportunity or the possibility of having a session on Sunday morning. I'm not 100% sure, but I'll try my best. But that would be subject to me getting few mails from you. So feel free to write to me if you want to discuss anything. Let me, for the time being, okay, if there are no, let me just stop sharing. I think so. Anyway, no, there is nobody. So yeah, let me just stop.